Good morning, all. In today's session, we will start with the first phase of the compiler design, that is lexical analysis. In today's session, we will cover the role of the lexical analyzer. What do you mean by the tokens, patterns, and lexemes? The specification of tokens. What is regular expression? The example based on regular expression. How we can recognize the tokens and the recognition of the reserved words and the identifiers. So now the role of the lexical analyzer in compiler design. As shown in the figure, as it is the first phase of the compiler, the main task of the lexical analyzer is to read the input characters of the source program, group them into the lexemes, and produce the output as a sequence of tokens for each lexeme in the source program. The stream of the tokens is sent to the parser for the syntax analysis phase. With the lexical analyzer to interact with the symbol table as well. So when the lexical analyzer discovers the lexemes as an identifier, it needs to enter that lexeme into the symbol table. So in some of the cases, the information regarding such kind of the identifier may be read from the symbol table by the lexical analyzer to determine what type of the token it is that is to be parsed to the parser. So which is shown in the figure. The interaction that is implemented, which will call to the parser with a lexical analyzer phase. So here, when we will call the parser, the function that will be used as the get next token. So this particular command will cause the lexical analyzer to read the character from its input until it can identify the next lexeme and produce it for the next token, which will return it to the parser. So sometimes what will happen that the lexical analyzer are divided into the two processes. That is the scanning process and the lexical analysis process. So the scanning consists of the simple processes that do not require the tokenization of the input, such as deletion of the comments and consecutive white spaces within the characters. The lexical analysis where scans the input as a sequence of the tokens as an output. So here the lexical analyzer will remove the white spaces that are there with the tokens and it will generate the token. So the next is what is token, pattern and lexemes. Basically the token is a pair that will consist of the token name and an attribute value. So basically the token name, that is an abstract symbol representation of a lexical unit which will contain a keyword, the sequence of the input characters that will denote an identifier, the token names that are the input symbols which the parser will process. A pattern is a description of the form that the lexemes of the token may take. So in case of the keyword, as a token, if we will consider as an example, the pattern is just the sequence of characters that form the keyword. For identifiers and some other tokens, the pattern is more complex structure that is matched by the many strings. Then the lexeme is a sequence of characters in the source program that matches the pattern for a token and is identified by the lexical analyzer as an instance of that token. So, with the help of the token patterns and lexemes, if we will consider an example, that is the printf, the total which is equals to %d and the score. So here, both the printf and the score are the lexemes, which will match the pattern for a token ID. And the the total which is equals to %d is a lexeme matching with that particular letter. So this particular example clearly specifies the token pattern and the lexeme. The another example for the tokens are, if we will use is the looping statement, that is if else statement. So here the if is my token where the characters I and f which will contain an informal description for that particular token, and the lexeme is again the if. If we will consider the else, then the characters are ELSE and again the lexemes are the else. If we will consider the token as a comparison, then the sample lexemes that is to be considered as the less than equal to, greater than equal to, not equal to. If we will consider the ID as a token, then the lexeme that is to be considered, the variable that is declared with that particular identifier. So here the example is taken as pi score d2. If we will consider the number as a token, then that particular number can be defined anything, which is the numeric constant. So here the example is taken as 3.140, 6.02. If we will consider the token as a literal, so that can be surrounded with a double quotes, which will be considered as a lexeme. So these are some of the examples related to the tokens. Now, the next is how we can specify the tokens. So basically, a prefix of a string s is any string that can be obtained by removing the 0 or the more symbols from the end of that particular string. So for example, if we will consider the banana as a string, then the prefix for that particular string is considered as the bn, banana or e. A suffix of the string s is any string that can be obtained by removing 0 or more symbols from the beginning of that particular string. So again, if we will consider the example as a banana as a string, then the suffix for that particular string is NANA, banana. Now, a substring that can be obtained by deleting any prefix or any suffix from that particular string. So for instance, if we will consider the banana, then the substrings are again the banana NAN. Now, the proper prefix, suffix and the substring of that particular string, here we will consider the example as a banana. Then the E is not equal or equal to that particular string itself. So that is the proper prefix, suffix or the substring that can be defined. A subsequence of a particular string is any string that can be formed by deleting 0 or more consecutive positions of that particular string. So here again, if we will consider the example as a banana, then the subsequence can be considered as BAAN. So these are the different specifications that can be used for the tokens. Then the next is, what is the regular expression? So the regular expression, or we can say the regex, is a sequence of the characters that define the search pattern. So now, how we can write the regular expression? So basically, the regular expression that can be started by understanding the special characters that can be used with a regex, such as the dot, the asterisk symbol, plus, question mark, and some many more. So we have to choose a proper programming language or the tool that supports the regular expression. Write the pattern for that particular special characters and the literal characters, and use the appropriate function or the method to search a pattern into that particular string. For example, here are some examples that are listed. So to match a single character with a set of the possibilities, we can use the square bracket. To match the 0 or more occurrences of a particular expression, we can use the asterisk symbol. To match the one or the more occurrences of the preceding expression, we can use the plus symbol. So these are the different examples we can use with the help of the regular expressions. So here some meta characters are given for the regular expression. The escape character is used for matching with the any character. The dot operator is used. To match with the digit, we will use the /d. If we want to check it is not the digit, we will use the /D. So there are many more meta characters that are used. Again, for the grouping with a regular expression, we have to use the square bracket, which will matches the characters in the bracket. If you don't match the characters, then that can be specified with a negation with a square bracket. For the either or, we will use the or symbol. And for the capturing group, we will use the round bracket. For the quantifiers, we will use the asterisk symbol for 0 or more occurrences. For 1 or more occurrences, we will use the plus. For 0 or 1 occurrences, we will use the question mark. And an exact number of characters, we will use the curly brackets. And to specify the range of the characters, we will use within the curly brackets what is the minimum and the maximum value. So these are some of the pattern matchings that are used to write the regular expression. Now, the next is the recognition of the tokens. For the recognition of the tokens, a different symbols is used, that is digit, which will specify the digits from the 0 to 9. So here, with a one token for the each keyword, the pattern for the keyword is same as the keyword itself. The number that can be used, which will specify with the digits, with the dot, which will be specified within the curly bracket. If you want to specify the ID, then that can be defined with the letter or the digit. So these are some of the recognitions are used to identify the tokens. For an identification of the tokens, here the terminals of the grammar that can be used as if, else, reload, id, the number. So these are some of the names of the tokens which the lexical analyzer will be used. For example, if we will use the less than greater than symbol, then the recognition of that particular token will get identified by the system with the help of the keyword reloop. So these are some of the recognitions that are used. Now, based on this, how we can identify the tokens? How many number of the tokens that are there with a given problem statement? So each and every identifier or the keyword or the round bracket or the semicolon, these are separately counted as a separate token. So here with the help of this particular example, if we will count the number of the tokens, so with this particular example, the number of the tokens are 26. So here the plus plus operator that will be counted as a one token. Switch is the one token. The opening bracket is another token. Input value is another token. Closing round bracket is another token. Opening curly bracket is another token. So likewise, we can count the number of the tokens. So basically, the lexical analyzer is responsible to identify the tokens. If there is an error with this particular problem statement that is given, then the lexical analyzer is not responsible for the correction of the errors. This is all about the lexical analysis phase. Thank you.